The last one, another wrinkle. 10-liter tank, so we're going to have to find molarity at the before we find K. 4 moles of hydrogen gas, 4 moles of oxygen gas, and 1 mole of water. And this is in the gas form, not the liquid form, so it falls into the equation. Start. And when you hit equilibrium, you've got 4 moles of H2O, find K. What makes this different is that you're starting off finally for the first time when we do these problems that you've got a product in the initial portion. So we've always had that I line and we've put zeros in for the products this entire time that we've done stoic, that we've done equilibrium, and it doesn't always have to start off that way. We've assumed it, but not anymore. Sometimes you have to account for it. Now we do. You can't always assume it's empty. So let's see what we get. How does that affect things? So 4, and we've got a mole here. I guess to be complete, we should make this 2 significant figures. Assuming. Okay. Well, now we're winding up with 4. Well, I'm no big city lawyer, but that's a plus 3.0. Well, look at our reaction. 2 to 1 to 2. That means hydrogen gas and water get consumed and produced at the same rate. Oh, we only go through oxygen at half the rate that hydrogen does. Well, let's see what happens here. Well, if this is water is plus 3, hydrogen has to be a minus 3. That's 1.0. Well, we're only going through oxygen half as fast. So if that's minus 3.0, well, half as fast of that is going to be 1.5. Oh, well, that means there's going to be 2.5 left, or at least in moles. Now we're in a 10-liter tank, so we've got to divide all these answers by 10 to get molarity. Well, that's easy. So this is a concentration of 0.1 molar. That's 0.25, and that's 0.40. Because again, we're taking our answers in moles here and dividing by 10. Moles divided by volume to get molarity. All right, let's solve for K. Products with the coefficient over reactants. Hydrogen gas squared over O2. No, you just plug and chug. That's going to be 0.16. 4 times 4 is 16. Now we just got decimal points. K is going to be big. I didn't plan it this way, but it's another 64. Oh, products are favored. Forward reaction is greater than the reverse reaction. At equilibrium, we have more products than reactants. Duh. Not so bad. What was the wrinkle here? You had to realize that you started off with a little bit of water in the tank. In the gas form, not the liquid form. Otherwise, we wouldn't have been able to account for it. Okay? It wouldn't have shown up in the equation. So there you go. 4 examples. I think you guys can do it. All right? If you have questions, send me an email. Otherwise, give it a go.